This section is on operations on polynomials. Okay, and by operations we mean addition, subtraction, multiplication, and division. All right, which we will get to, but not yet. So we have to set up some things first. So first of all, I'm going to define polynomial. All right, the word polynomial. And it is defined as two or more monomials connected by addition or subtraction. And here's an example. 2x cubed monomial, 4x squared monomial, negative x, negative 7x, and negative 8. Okay, and they're connected by addition and subtraction signs. All right. Now we have some vocab terms that we need to talk about. The first is degree, and the degree of the polynomial is the largest exponent of the variable. So in this case, this polynomial would have degree 3 because x to the third power is the highest power in the polynomial. The leading coefficient is the coefficient of the degree term, which in this case is 2. All right. The constant term is the term without a variable, here negative 8. And finally, standard form. Standard form, this polynomial is written in standard form because the highest degree term is listed first, and it's going in descending order. The third power, second power, first power, zeroth power. Okay, so it's called descending order. All right, so this is called a standard form. So as our first example, let's rewrite the polynomial in standard form and then state these various things. So first of all, standard form, we're going to just reorder these things, listing the highest order first. Okay, so it's positive 4. The sign goes with it, right? Positive 4x cubed minus 2x squared plus 5x and then plus 8. So this is written in standard form in descending order. The degree is 3. The leading coefficient is 4, and the constant term is positive 8. Okay, so those are just some vocabulary terms that we can apply to polynomials. Let's find the sum, the difference, the product, and the quotient of these polynomials. Okay, so first the sum, and we can sum them by simply taking the first one and plus the second one. Now in the case of addition, we can just ignore the parentheses, just list it like that, and now we can combine some like terms. For example, I have the x terms, which I will put in circles, ovals. I'll put boxes around the constant term, and I'll underline the x squared term, and I'll leave the cube term alone. All right, and then we can combine like terms to get 2x cubed minus 3x squared minus 4x, and then minus 15. Okay, now another way to do this is to line it up vertically, as if you were adding multi-digit numbers. Okay, we can line them up here. We have to line up just like if we were adding, I don't know, 472 plus 78, we have to line up the ones term and the tens term. So we're going to line up like terms and then just add them vertically. Okay, so negative 12 plus negative 3 is negative 15. Negative 4x, that is itself. So we can line them up vertically as well, just like we would do with numbers. Now let's find the difference. So the difference of the polynomials is here. Now you got to be careful here because there's actually a negative 1 out in front of that thing, so we got to distribute the negative 1 through the second set of parentheses. Okay, so that becomes negative x and positive 3. The first polynomial remains the same, but the second one, the signs change. Got to be careful of that. Okay, from then on, it is as it was before. We just group like terms together and then combine. And in this case, we get this for our answer. Or, once again, we can line it up vertically. Okay, so we line it up like this, lining up like terms, line it up by degree, and then subtracting is the same thing as adding the opposite. So what I like to do is I just like to change the signs and then add, because adding, for many people, adding is easier than subtracting. So I just change the signs and then add. Okay, and notice negative 12 plus 3 gets you to negative 9. Negative 5 plus negative 1 gets you negative 6, etc., etc. Okay, so subtracting is the same thing as changing the signs and adding. All right, now let's multiply. And to multiply, we're going to do this. Now you could do this various methods. You could do the box method, for example, but instead I'm going to distribute. All right, I'm going to do it this way. So I'm going to multiply the the 2x cubed times the x, and I get a 2x to the fourth. All right, I'm going to do this in red. And then I'm going to distribute to the negative 3, and that times that is negative 6x cubed. All right. Okay, now let's work with the negative 3x squared, okay, which I'll put in blue. That times that is negative 3x to the third, and that times that is positive 9x squared. Okay, now let's work with the negative 5x, which I'll put in green. Negative 5x times x is minus 5x squared, and then this would be positive 15x. And then finally, I'll distribute the other one, which I'll put in orange. Negative 12 times x, negative 12x, negative 12 times negative 3 is positive 36. All right. Okay, now we can combine like terms again. I got some x cubes there. I got some x squared terms there. I got some x terms there, which now we can combine these to get the following. 2x to the fourth minus 9x cubed plus 4x squared plus 3x plus 36. Okay, so that's by distributive property. Or, once again, we can line them up vertically, as you would if you multiplied multi-digit numbers. And so to multiply multi-digit numbers, you multiply one pair of digits at a time. And we're going to do the same thing here with the terms. All right, so I'm going to multiply this term times this, and I get positive 36. Then I'm going to multiply that times that. Negative 3 times negative 5x is positive 15x. Then when I multiply that, negative 3 times negative 3x squared is positive 9x squared. And then I multiply that, negative 3 times 2x cubed is negative 6x cubed. All right, so I did that. Now I'm going to work with the first one, but it's important to line them up by degree, okay? Because you need to match up so we get like terms. So when I multiply the x times a 12, it's going to be negative 12x, which I'm going to line up here. Okay, and when we multiply this, x times negative 5x is negative 5x squared, which I will put beneath the x squared term here. This one, x times negative 3x squared is negative 3x cubed. And then finally, x times 2x cubed is 2x to the fourth. Okay, and now I'm just going to add them vertically. Okay, and when I do that, we get the same thing we got up here. Okay, so multiple ways of multiplying, just whichever you choose. Okay. Finally, let's take the quotient. Okay, so we do f of x divided by g of x, which is the same thing as f of x over g of x. Okay. Now we're going to do this by long division. Okay. Now you learned how to do long division with numbers back in late elementary school, probably, and so now we're going to do this with polynomials. All right, so we're going to line it up, same thing as here. And now I'm going to look at the first term in each polynomial, okay? And I think I have to divide 2x cubed by x, okay? Or, the way I like to think about it, what times x equals 2x cubed? What times x equals 2x cubed? And the answer to that is 2x squared. Okay, so we write the 2x squared up there. Now we multiply. We multiply the 2x cubed by each term out here. And I get x times 2x squared, which is 2x cubed. 2x squared times negative 3 is negative 6x squared. Okay. Now we're going to subtract, or better saying it better, change the signs and add. All right, changing the signs and add, we get 0 there, and here we get 3x squared. Okay. Now we're going to bring down the next term, just like we do with dividing numbers. Okay, we're going to repeat the process. Okay, bring down the next term and then repeat the process. What times x equals 3x squared? The answer to that is positive 3x. Okay, then multiply. X times 3x is 3x squared. And negative 3 times 3x is negative 9x. Okay, and then change the signs and add, and we get 4x. That goes away. Bring down that last term. And repeat, what times x equals 4x? That's positive 4. And then multiply, 4 times x is 4x, 4 times negative 3 is negative 12, and it adds to 0. Okay, so that's our dividing it by long division. Okay. Okay, turns out there's another way of dividing. Okay, that's oftentimes easier than long division. And that's called synthetic division. Okay, now with the cool part about synthetic division is we focus only on the coefficients. We don't focus on the x's at all, at the variables at all. We only focus on the numbers. So we're going to take the numbers of this polynomial, and I'm going to arrange them like this: 2, -3, -5, -12. I'm going to have a little box out here and a line out here. Okay, and the number we put in the box is going to be the 0 of the divisor. And x minus 3, the number out front here is called the divisor. And the 0 of that divisor is 3, because 3 minus 3 is 0. So we're going to take 3 and we're going to put it into here. Okay? All right, now watch what happens. First thing we're going to do is going to bring that first term down. Okay? Then we're going to multiply 3 times 2, and then put the answer in the next space. And then add. And then do it again. Multiply, put it in there, and then add. Multiply, and then add. And here's what we get. Okay? Now, focus on these things right here, the 2, the 3, and the 4. Those are the numbers here. The remainder term is 0, but I'll get back to that in a minute. So what's left here? What we do here is we take these, the 2, the 3, and the 4, as the coefficients of a polynomial that is less by 1 degree. The original polynomial was degree 3, so we take 1 degree less, so we have degree 2. Okay, so that becomes the coefficient of the x squared term, that becomes the coefficient of the x term, that becomes the constant term. And the last term is a remainder, which in this case is 0. All right? So by dividing, we got this as our answer. And notice, if I go back and look at the long division way, we're kind of doing the same thing. Okay, we're bringing the first one down, 2, all right? And then we're multiplying and adding, multiplying and adding, multiplying and adding, okay, over and over again. But we ignore the x's. We only focus on the coefficients, which makes it nice and tidy, okay? And this is called synthetic division. Let's do another example of synthetic division. Let's divide this by this. Okay? So we line up the coefficients like this. Okay? We put the 0 of the divisor in the box. Now the 0 in this case is going to be -2. All right? Now, bring the first term down. Multiply. Add. Multiply. Add. Multiply. Add. And once again, we get a remainder of 0. So the answer then is taking these coefficients and writing them taking these numbers and writing them as coefficients with a polynomial of 1 less degree. In other words, that right there, 3x squared minus 4x plus 6. That's it. That's synthetic division. Really, really simple. Okay? A lot nicer than long division. At least I think so. Okay, now there's a number of things you have to, or a couple of things you have to watch. If I want to divide this by this, notice that this x cubed term, the next term is the constant term. We're missing some degree terms of x. In order for synthetic division to work, we need to include all of the degrees of x, which we can do by just putting coefficients of 0 in there. All right, so we need to write it like this first before we set it up with synthetic division. Okay? Now, from now on, it's the same thing. We take the 0 of the divisor, -1, and do the same thing. Bring the first term down, multiply, add, multiply, add, multiply, add. Okay? And what you get is x squared minus x plus 1. Okay, as our answer. Now, to show that works, let's check it. Let's take x squared minus x plus 1 and multiply it by x plus 1. If this answer is correct, then after multiplying these two, I should end up with the original polynomial x cubed plus 1. Let's find out if we do. Okay, multiplying that, and then multiplying that to get negative x, multiplying that to get x squared, or 1 times a polynomial is itself, right? Okay, then x times 1 is x times negative x is negative x squared, x times x squared is x cubed. And after adding, look what happens. We get x cubed plus 1 back. Okay? So, moral of the story, make sure that each degree term is represented, which you would also have to do if you did this by long division. All right? So, synthetic division is a real nice and tidy way of dividing polynomials, and it streamlines the process for the stuff we're going to do next, which is finding the rational zeros of a function. Okay? Now, first time we're going to use a graph. So let's use the graph of this function, shown, to find 1, 0 of this polynomial, which I'll clue you in is this graph is the graph of this function. Okay. So we want to use the graph to find 1, 0, and then use synthetic division and factoring to find the other zeros. Okay. So I'm looking on this graph where it crosses the y-axis. It crosses it 3 times, which makes sense because it's polynomial of degree 3. And, oh, right there. Okay, right there. There's a 0 at x equals negative 2. Okay, so when setting up synthetic division, 6, 25, first of all, are all degrees represented? Yes. So then 6, 25, 21, and negative 10. And then the 0 that we're going to use is at negative 2. I can see that from inspection by looking at the graph. All right, now let's go through our synthetic division process. Bring the 6 down, multiply, add, multiply, add, multiply, add, and we get a remainder of 0, which tells us that yes, indeed, negative 2 is a 0. All right. Okay, well then what is the polynomial left over? Well, it's 6x squared plus 13x minus 5. So what that means is I can write this original polynomial as this, x plus 2, because negative 2 is a factor, okay, times this. Now, is this, now we need to factor this, okay? I wonder if it's factorable by easy methods or methods we already know. Well, let's find out. So whatever method of factoring you use, test this to see if it's factorable without using the quadratic formula or such. All right, so my method, I'm going to put factors of 6 out here and negative 5 out here. I'm looking for combinations that add to a positive 13, which turns out to be this one right here. Okay, because 2 times negative 1 is negative 2, 3 times 5 is positive 15, and they add to a positive 13. So that's the pairing that I want. Okay, so that means that this breaks down to this. X plus 2 just comes along, and then 2x and 3x, these are never in the same parentheses with their partners, so the negative 1 goes over here and the positive 5 goes over here. All right, and now it's factored. Whatever method of factoring you use, we should all get to this place. Okay. Now, to find the zeros, set this equal to 0. All right, which means setting each of these equal to 0. Well, this was kind of already done for us. We know that's a 0, but we have to solve these. So 2x plus 5 equals 0, and then 3x minus 1 equals 0, which we solve. Take the 5 over, divide out the 2. We get x equals negative 5 halves. And then add 1, and then divide by 3, and we get this. Okay. Now, we would like a way to check these to see if they're correct. And the way we can check them is just by inspecting the graph. Negative 5 halves is right there. That checks out. 1/3 is right there. That checks out also. So we can use the graph to check our answers. Okay? Okay, one more example to do, and that is to find the rational zeros without the aid of a graph. Okay, this is a little tougher, but synthetic division is going to help us out. Okay, now the first thing we do is we set the function equal to 0, like that. Okay, now as it turns out, the possible factors of a polynomial of this type, where I have a as the coefficient of the highest degree term, in this case x cubed, la 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 la. In this case, d is the constant term. Okay, as it turns out, the possible factors of this polynomial are the factors of the constant term divided by the factors of the leading coefficient. Okay, so in this case, factors of d over factors of a. All right, now, so the possible factors of this, the one we're working with in this problem, are the factors of -2 over the factors of +3. Okay. Now, the possible factors of -2 are plus or minus 1, plus or minus 2. The factors of +3 are plus or minus 1, plus or minus 3. You have to take plus or minus because -1 times -3 equals +3, you know, +1 times -2 equals -2, all that stuff. So we have to take the plus or minuses of both of these. So the plus or minus of all the factors of, in this case, 2, and all the factors of 3, which are just this. Okay. Now, the possibilities are all of the possible combinations of this. So for example, 1 over 1, which is 1, 2 over 1, which is 2, 1 over 3, which is 1/3, and 2 over 3, which is 2/3. So there are 8 possible factors here, plus or minus 1, plus or minus 2, plus or minus 1/3, and plus or minus 2/3. And we need to test to see which are the factors, okay? Which can be a bit of work. We're looking for a remainder of 0 when we use synthetic division. Okay, once we get a remainder of 0, then we got it. So I'm going to set up my synthetic division here, 3, 4, -5, -2. And just by trial and error, we have to pick one first. Well, I'm going to stay away from these fractions until I'm forced to try those. I'm going to start out easy. I'm going to just try +1. Maybe we'll get lucky and that one will work, right? So let's go through the process. 3, multiply, add, multiply, add, multiply, add. Wow, how about that? That first one worked. That was cool. Okay, so we know that +1 is a 0. All right, and now what's left? We have 3x. So this, the original, can be written as x minus 1. All right, the 0 of +1, and then 3x squared plus 7x plus 2. All right, the 1 shows up here, and then that goes there. All right, now, is that factorable? I hope it is. So let's test it. I got factors of 1 and 3, and I got factors of 2, and I'm looking to add to +7, which they will with this combination. All right, so that's cool. And so what I get is x minus 1, and then 3x plus 1 and x plus 2. So however you factor, we should end up with this. All right, now we separate and we solve each one. X minus 1 is equal to 0, 3x plus 1 is equal to 0, x plus 2 is equal to 0. Well, x equals 1. We knew that from synthetic division, but I'm still going to do it this way anyway, because maybe I did the synthetic division wrong, right? So 3x plus 1 equals 0, subtract the 1, divide out the 3, and then subtract the 2, and we get these as possibles. Now, we need to check all these. We don't have a graph to help us out, so we have to plug each of these back into the original polynomial, and I hope that it equals 0. So let's test 1 first. All right, let's test 1 by putting 1 in there, 1 in there, and 1 in there. Okay. Well, 1 cubed is 1 times 3 is 3. Okay. 1 squared is 4 times 4 is 4. 5 times 1 is 5. So we get 3 plus 4, which is 7, minus 5 minus 2, which is 0. So that one checks out. So x equals 1 is a solution. Now, let's check -1/3. So I put -1/3 in there, -1/3 in there, -1/3 in there. Now, -1/3, well, actually, long story short, if you want to go through this, pause the video and walk your way through this. But to save a little time, I'll say it does check out. Okay, you can pause this and go through step by step to prove that to yourself, but or you can just believe me on that one. It does check out. All right, so x equals Negative 1/3 is a solution. All right, one more to check, and that's negative 2. And I'll cut to the chase. That also works out. So x equals negative 2 is also a solution. So really, we can find the zeros of any polynomial by the use of the general method described on the previous slide and synthetic division. Okay, sometimes it's a bit of work, all right, but it's a lot easier than trying to do it by log division. Okay, all right, now go practice these skills with the practice problems.